Hi, let us look at data visualization, specifically visualization of categorical variable, okay? Yeah, so again, I've made the code available here, which is different code for visualizing a categorical data. So all you need to do is just to copy that part of the code, and then you'll be able to follow along, okay? Yeah. So let's get to it. Yeah, you can copy all the way here. And that ends the visualization of categorical variable, and then you paste it and you follow along. So we are going to use the hints data. So again, first of all, what we are going to do is to be able to call in our data or import the data. So the data is found here. So I'll bring in the data so we can see the names of the data. We can see the statistical sum of the data. Again, we can see it has some minuses in it and stuff and others. So it tells you there are some missing information. So we might want to use what is called deleting the missing data, which is called the listwise deletion. Okay. So before I do that, let me attach the data so that I wouldn't have to use the $ anytime I have to call a variable from the data. So from this part of the code, again, I would have to, I'm deleting all the zeros from the data, okay, from these variables. Any all the minuses from these variables, I'm going to delete it, okay? And I'm using, again, the data, the concatenate function for all the variables I want to delete, and with this end function separating or end sign separating each of the variables, close the concatenate function, bring your comma for all columns of the data set, okay? So let me run that part of the data. Now, we can also look at the names, okay? And then let's look at the statistical summary. So you can see that for those variables, the first one, it has some minuses in the statistical summary, but this time there are no minuses in the statistical summary. So it tells you that now all those unwanted information have been eliminated. So now we are good to go ahead to visualize something, okay? So first of all, let us look at visualizing the smoking start, okay? We want to start with categorical data visualization, which we want to look at bar graphs or bar charts, as you may call it. So we are using a function called the bar plot. And then before you develop a bar chart, you'd have to have a table of that variable, okay? So we have a table of, so a table function of the smoke star, okay? And then we put it in a bar plot function. So let us run it. So here is what we have. You can see, so there's a bar plot for this particular variable, which is the smoking status, okay? Yeah. So now, before then, we are still having the minus because it is making use of the original data, okay? But then the new data, which was clean, we haven't attached it yet. So it's still recalling the smoking stuff from the original data. So let's attach it, okay? So now we have attached the clean data, and then let us run this line again. Okay, now we have 3 categories of the smoking status without the minus sign, as you saw before. You see, before it has the unwanted information within the data set, but this time we don't have it. So next, another thing you can do is, rather than using the table function within the bar plot function, you can decide to assign the table of the smoking status to another, you can assign it to tab. You can give it any name, okay? So I'm creating a table and I'm assigning it to tab. So this is the name I'm calling, okay? So with that, you can just go ahead and then, for instance, I can just say bar plot of what? Of tab. And that should still be able to give us you see the same visualization of the tab. But now that I have the tab, I have created a table, I can use it in several different ways. But now what I want to do is I want to include labels, okay? I would like to, because I mean, visualizing this have no meaning, okay? So we would want to include some kind of label so that we know what one represents, two, three represent. So in the hints data, the smoking star one represent current smokers, former smokers, and never smokers, okay? And never smoke. So we are giving it, we are assigning it to labels. You can give it any name and using a concatenate function, which is a vector we are creating, which is a vector of string variables, okay? So this is what we have. So now let us run it. So once we have run, now within the bar plot function, we can have what is called names.arg, which allow us to give the labels of the bar plot, okay? So we already have the tab, which is the table of our smoking status. And then now you add in the names argument to be able to assign the labels. So let's run it. Okay. So now this is more meaningful. So you know that among the smoking status, the never smokers has the highest frequency, right? But this can even, we can even also extend this more further by beautifying it, the graph, right? So in order to do that, again, using the bar plot, the tab is the table we created, the names.arg is the labels in which we assign. And then now we are going to use what is called the main. Main is you assigning title of the plot, okay? So we are going to call it bar graph of smoking status, okay? Or you can say distribution of smoking status to make it more meaningful, okay? You can say distribution of smoking status. So we can say distribution of smoking status. And then we can go, and then we want to give it some color, okay? So we are giving, within it, we are giving this color, the orchid color, but you can give it yellow, green, whichever color you want. We are putting it in the quotation marks. And then we are giving it name, the X label name, which is, we are calling it smoking status. And then the Y label is going to be the frequencies of each of the smoking status, okay? So let's run this line of the code. But instead of writing a long line of code like this, sometimes you can enter, okay? So that it can reduce the length on how long you can actually write the entire code, okay? But again, once you run it, it runs everything. Let's run it and see. Okay. So now we are able to see the distribution of smoking status, which is current, former, and then never with what? The frequency. Now it's getting prettier and prettier, right? So next, we can also decide to give the individual levels of the smoking status or categories different colors rather than just having them have a single color, okay? So again, over here, you can decide to use the enter to ensure that your code doesn't become too long. And you can again use enter to ensure that it doesn't become too long. So we have, again, the bar plot of the tab, the names, which was the label we created here, the vector labels, and then the title of the plot, which we said we want to give it distribution of smoking status to make it more meaningful and very communicatable. And then we have the smoking status as the x-axis, and then we have the y-axis as the count, okay, or the visualized part of it. The y-axis as the frequency or the count. So let's run it. Okay. So now you can see we have here, you can see it's looking quite pretty. We are able to observe every individual bars in a different color. Okay. Yeah, so now another thing you can also do is rather than using writing your own colors, okay, creating a vector of the colors for the 3 different categories, okay, you can actually use the rainbow, okay, and then you can just give it 3, telling that you need 3 different rainbow colors to represent each of the bars, okay. So over here again, after the comma, you can enter just to shorten your code rather than to make it very long, okay. So now we are going to use the rainbow colors instead of the individual color in which we decided to use, okay. So depending on which color you want, so nowadays the rainbow color which was randomly chosen, which is red, green, and blue, okay. So next we can also, what we can also do is we also have what is called the heat colors, which we can also use rather than the rainbow colors. So we can use the heat colors of 3. So we want 3 colors from the heat color function. So we have heat color and then we want 3 colors. So we can go ahead and then run it and see how it differs. Okay, so these are the heat colors, okay. And then we also have what is called the terrain, the terrain colors, okay. So let's, again, we can enter here just to shorten our code. So using the terrain colors rather than the heat colors, we can also get 3 different colors for our plot. Let's run that line of the code. So these are the terrain colors, okay. Again, we could have changed it from bar plot, bar graph of smoking status to distribution of smoking status to make it more meaningful. Okay, so now what if we are interested in seeing a bar plot which is side by side to each other? Okay, so you want to see 2 different distribution of a particular variable sitting side by side. Okay, so in this case, again, using the same tab, which was a table we created from the smoking status. Let me enter here. Okay, so we can use what is called the par function, which is within that function, we create a vector which is having given it the number of rows and then the number of columns. Okay, so this one allows us to create a plot on the same panel, create 2 column panel plot, which is 1 row and 2 columns. Okay, so if we oops. So if we go and then let's run that line of code, which is this line of the code, okay. The par function having, so this having a multiple panel plot, okay. So now this is actually going to give us a panel plot of 1 row and 2 columns. So let's first of all, let's run this particular bar plot, which is again using another color feature called the topo colors of 3, okay. Okay, so let us use that one and then let's run it. Okay, so this is what we have. Now you are going to observe that there is going to be another panel right to the right, okay, which we are going to have that panel also. It is going to have different color, which we are going to give it the color choice we are making is the mc.colors, which again we want 3 colors. Let's run it. So you can see now we have, so you can see we have 2 different plots sitting side by side. And that's because of we use the par function, okay, to show that we are actually, we need a 1 by 2 panel plots, okay. Then also, we can also use the legend function to actually have the legend of the plot, okay. Particularly the last plot, we can actually include the legend where we said that the legend means we want the names to appear on the plot for each of the categories we have or the color difference we have, okay. So we are going to put it at the top left corner, okay. And there's how the structure of it in which we want to. And then we want the labels. Now remember, we actually developed the labels, and then the labels we have was what? the names of each of the categories, okay? So within the legend, the position of the legend, the labels of the legend for the categories, the structure of the legend, and then the color field of the legend. Now remember, we are doing it for this particular plot. So we have to make sure we are consistent with the color feature, okay? So let's go ahead and then run it. Okay, so now here we have it. So you can see that we have this particular plot, which is actually showing. So, yeah, which is giving us the what? The names of the, so there is the legend giving us the names for each of the categories of smoking status, okay? So that we are able to understand what each column is. Now, if we want to move it back to just a single plot without side-by-side plot, just a single panel plot. Now in the path function, we have to move it to 1 by 1. Okay, so we have to change it from 1, 2 to 1, 1. Then now that gives us a single plot. Okay, so it tells you that if you want even 4 plots on the same panel, you can have 2, 2, which means 4 plots on the same panel, multiple plot, right? So we want it back to single plot. So with that, we can go ahead and then again, we can decide to run this part of the code again. And then now we can write the legend again, and you can see the legend. So now it is just a single plot. Okay. Now let us look at pie chart. Okay, because with the pie chart, now we can use the pie function to create a pie chart. So a pie chart of what? A pie chart of table of the smoking status. So we could have just used tab because we've already assigned tab to the table of the smoking status. But over here, we decided to write all of them, but that's okay. And then we are using the topo.colors, okay? Let's run it. So there's what we have. And then next, we are going to have, again, different colors in which we are assigning the colors. We could have changed this one to red, yellow, green, but we are just assigning the colors. So we are creating a vector of the colors within the pie function, okay? So the pie of our data, which is the table of the smoking status, and then the colors. So there's what we have. Now, again, let us, this is just similar to what we did before, where you assign tab to the table of the smoking status, and then rather than writing the table of the smoking status, you use the tab which has stored the table of the smoking status, okay? Okay, so now what we are also going to do is we are going to create a much prettier pie chart, okay? So now we have the tab of the smoking status. Then we are going to create a label, which we are calling it LBLS, okay? That's the label, the new label name we are giving it, okay? Which is current, former, and then never. And then what we are going to do is we are going to assign it a percentage, okay? So we need a percentage. We need a percentage for each of the, we are creating a percentage from the table. So, and then rounding that percentage, okay? So we say round for each value within the tab divided by the sum of the total of the table, that's sum total of the table, and multiply by 100, and that gives us the percentage, okay? So now we can actually create a label in which we are actually going to paste it into our pie chart, okay? So we say that LBLS of what? Paste function, we are using the paste function of the labels and then the percentage we have created here. So of the labels and then the percentage, okay? We are storing it into LBLS, okay? So let's run that line of the function. So then we now want to see, we also want to assign a percentage sign, okay? So also in the LBLS, we are also within the we are creating another LBLS, And then we are going to include percentage sign within the LBLS, okay? Separated by what? Separated by the quotation, the quotations, okay? And that is going to add percentage to our pie chart, okay? So let's run it. Now we can go ahead and run the pie of tab, which is the table of the smoking status, and then the label we created, which included the percentages, and then also the percent, and then the names of each of the categories of the smoking status, okay? So now we said labels equal LBLS, which is this one here, which we have created. Okay, so now we are given a pie chart of smoking status, which we could have said distribution of smoking status, okay? And then the color in which we are using is, again, we are using the topo.colors, okay, which we need 3 colors. So let's run that line of the code. Okay, so now you can see we have the different names of the sector of the circle along with their percentages, right? So from here, you can see that those who have never smoked are 40% of the data. Okay. Sorry, that's 64% of the data have never smoked. And then also, we can also create another, let's create another legend, which we are calling it, again, we are creating another labels, okay? So the labels, we are calling it labels, which is creating a vector of labels, okay? And then now we want to give it a legend. So within the legend, again, we want it to be at the left top. And then we want you to give us the labels, which is these labels we have created. And then this is the structure of the box which it should create for the legend, how wide we want the box to be. And there's the field, which is consistent with the colors we have here, which is the topo.colors, which we want 3, right? So let us run it. Okay, so now you can see. So now we're able to know what blue, green, and then yellow stand for. Okay. Now you can even create a more prettier pie chart, which we have the 3D pie chart. Okay. So with the 3D pie chart, you have to first of all install a package called the Plotrix. Okay. I have already installed that package, so I will just have to load that package. Now, once I have loaded that package, again, I'm going to define a label, okay, which is a vector of the levels of the smoking status, okay? Now, I'm using a function which is called the pi3d, okay? So with the pi3d of the tab is the table of the smoking status. And then now I have the label equal labels, okay? The labels over here equal these labels in which I have created here, okay? And then I want it to explode, how I want the pie chart to actually explode, which is to divide, okay, into some kind of, divisions, the way in which you cut pizza into pieces. Okay, and then again, the main equal, which is the pie chart of what? Quality of care, okay? Yeah, so what we are going to do is, let's, this time, if you want a pie chart of quality of care, so let's go ahead and then let's run it. Okay, so this actually still is a pie chart of the smoking status, not quality of care. Okay, while we could have created the quality of care table, okay, the smoking status. Okay, we could have created a table for the quality of care, which we could have simply said that, okay, we are creating a tab, so we are assigning that tab, which we said should be equal to table of what? Of quality of care, okay? So we can actually run it. Now we can go ahead. So we have the labels. And you can go ahead and run this quality of care, and then you can see it is having the quality of care. But this time, what then it means is that we have to be able to change the labels, because the quality of care, the labels is, we have the excellent, we have excellent, we have very good, we have good, we have the fair, and then we have the poor. So that's the quality of care in which we have, okay? And in this case, we could have just said, okay, run this, and then now we can go ahead and then say, give us the quality of care. So let's look at it. Okay, so we want this. Okay, so now we have the quality of care after you have run. So now this one actually gives us the distribution of quality of care, and then you can see right here, okay? So this is how you can actually, look at it. And then we also have to, in case we also need to include some kind of explosion. Now remember this one over here, explode, tell you how much you want the division to actually happen, okay? Okay, so let's run this. And this right here give us the labels, because we are using the quality of care. So the labels of the quality of care, which we can run it, and then we can actually have the legend, okay? And there's the legend of the quality of care, okay? So there's how you can actually have this pie chart develop, okay? Now you can also have two categorical variable in which you would actually want to show some distribution, which we'll talk about it, okay, in a separate video, okay?